Okay, so we're ready to start. Hello, everyone. I'm Gardner Event. I'm a professor at King's, and I'm the director of the King's Institute for AI. Welcome to this session on perspectives on AI, Lightning Talks. The Festival of AI is one of the flagship events that we run at the Institute because our vision is that AI needs not to be studied only from within one disciplinary boundary, and also needs not to be studied by one institute alone. So we organize this festival where we put together different disciplines, and put together society and other universities as well. And there's no better example of today's session, where we have 6 speakers from different academic disciplines, different career stage, and different institutions. Okay, so the way we're going to run this event is each of the speakers will have 7 to 10 minutes to deliver their presentation, and after that we'll open to the Q&A. Okay, so housekeeping, please switch your mobile phones off now to silent. There is no alarm, fire alarm drill, so if we hear a noise, it means we need to take action. Okay? And let me, without wasting any more time, let me introduce the first speaker, Arunav Das, who is a PhD researcher within the Department of Informatics at King's, and also a research fellow at the Open Data Institute. Arunav's research focuses on building multimodal and omnichannel question-answer system over structured, semi-structured, and unstructured data, combining the advantages in data streaming services with state-of-the-art development in knowledge graphs, LLMs, and NLP, with a particular emphasis on data provenance, consent, privacy, AI safety, and responsible AI. Wow, you covered everything. Okay, great. This floor is yours.
Thanks a lot, Caroline. I would also like to start with a big thank you to all of you for making time to be here today, especially braving the wet weather conditions. I'm grateful to King's for the platform, and grateful also to the team behind these events, because I know how much goes into arranging these events. Once again, I'm Arunav Das. I'm a PhD researcher with Department of Informatics, and I'm here today to share some of my perspectives linked to some of the aspects of my research, because in the given time it's not possible to cover everything. So I'm going to cover the evolution of knowledge from Alexandria to Alexa. And The way I'm going to link it to my research, which is question answering system, is using 4 foundational pillars. The first pillar is the role of a purposeful knowledge seeker. Now, the definition of a purposeful knowledge seeker is someone who is seeking some information for either taking an action or making a decision. So it's not a casual kind of curiosity-led. Specific for this perspective, that's the definition I'm using. Then, second pillar is very much about the sources of knowledges, and these are examples of that would be books, blogs, articles, or even computer-generated content going forward. The third pillar is the interface. And the interface could be either human. So think about the times when we go to library and interact with the librarian perhaps, or computer. So our interface to the sources of knowledge is a digital media and no longer human is involved. The fourth dimension is beyond the interface, what are the interactions? Because as the interface changes, the interaction with the interface changes, our ability to understand, comprehend, assimilate what we get back from those interactions also changes. So using those 4 pillars, I thought if we were to plot a timeline of how this methods of seeking knowledge and our experiences of gaining knowledge has changed over a period of time, I was wondering about what would that have been back 4th century before the Christian era to seek information, to go through all the maybe books, journals at that time, written in different formats, different languages, and then moving on from that period to the period of 1990s, where we started getting internet, and most of the information was available on internet. This was also the time when things which were primarily physical started getting converted into a digital equivalent. So digitization started happening around this time as well. The third one is 1997, when Google kind of filed the patent for Google search engine. So that's the 4th landmark I'm going to use. And the 5th one is, I think 30th of November will go down in history as one of the transformational points. So just want to say that these are not discrete kind of landmarks, and these are not transformative in the sense that at that point in time something happened. I'm just using them as milestones because over a period of time they have coexisted, they have been co-used. So nothing is like discrete. And then if you go back to encyclopedias, for example, I was looking it up and the last edition was physically printed back in 2010. So there was an overlapping period when all of this was happening. Also the internet has been there since 1980s, but I'm using 1990s from an adoption point of view. Similarly, internet search engines have been there before 1997, but I'm using Google search for mass adoption. And surprisingly, chat agents or conversational agents have been around since 1960s. So Eliza was the first chatbot. So again, the point in time is just indicating when the mass adoption happened, not indicating when the actual application started getting developed or researched. So I know I've thrown some concepts and terms. I just want to ground some of them with a frame of reference before I go forward with the rest of the concepts and the frameworks. So the first one is knowledge, and this is just one way of looking at it, justified true belief. There will be debates and discussions around whether this is the right definition or not. We do not have, unfortunately, time in today's session to go through that, so please do accept it as it is, so that the rest of the talk can follow from it. The knowledge repository, I'm going to use this term as well, and by that I mean physical or digital stores of written knowledge. So think about both of those medium. I'm going to use a knowledge spectrum to define the evolution, and the spectrum is cultivation, which is called creation, as well as curation, and consumption, which is called congruence and credence. And I'm going to come to that shortly as well. And I'm going to break down these methods as traditional versus technological. So a little more on traditional methods. So even though they cover different forms, physical and digital, my definition of traditional methods is information as it is presented back, so as it is written. Whereas technological is information which is processed. So behind the scenes, there is that written information, physical or digital, but technological models are kind of processing it before we consume that information. So in that regard, I'm grouping all the books in the libraries, encyclopedias, and even Wikipedia, which is online, into the traditional methods, and I'm going to refer to internet search engines and chatbots and voice assistant on the technological models. In terms of perspectives, three different aspects of the perspective. First of it is a theoretical framework around how this whole interaction, exchange has evolved over a period of time. Then a practical, experiential kind of example of how it feels like in this world today. And then other considerations which are not part of this talk, but you may want to consider that taking it forward as well. So starting with the first one, which is the knowledge cultivation and knowledge consumption. Now, this is about difference between the traditional and the technology. So in terms of when we think about the creators, traditionally the creators were just humans. And traditionally they were mostly scholars or researchers. As we move into the new paradigm of technological, those humans, researchers, academics are still involved in creating the knowledge, but now we have other people from the broader society also getting involved. So blogs, posts, articles, etc. And then taking it further, some of the content is even generated by algorithmic models. So not all content is now created by humans. There is an additional layer of how algorithms are also creating the new content. Now, if we think about the curators, the way the roles have changed is traditionally we used to have editors who used to look at the piece of work and then define or refine what should be the final piece. If you look at the technological models, there is no concept of editor. We have a concept of moderator. And that kind of influences what information is presented back to us. Now going to the consumption kind of framework, again comparing the traditional versus the technological. In the traditional way, the consumption was very much an interaction with a human. So, and when we used to go to the libraries, for example, or even if we search some digital content like Wikipedia, we might still go through an index or a catalog. So the way of searching method was going through an index, going through a catalog, going through a topic, and then finding the information around it. Whereas in today's world, there is no cataloging or indexing. We just put a sentence or a question and we get the information back. So the consumption patterns have changed as well in terms of the specificity of what we are looking for. How do we put to the knowledge source and the interface to get the information back? If you think about the credence of it, now we have relied traditionally on the editor. I was talking about the curators in terms of the content, the factual accuracy of whatever we were reading or searching at that point in time. Now today, with the technological models, it may not be always possible to get the source of the information. Where is it coming from? Because these models may have been trained on a plethora of sources from different kind of bases, articles, blogs, academic journals, books, etc. One never knows unless they are citing the sources. Now some of them have started doing it, but when ChatGPT came on board back in 2022, it was not citing any of the sources. So one never knew what was happening behind the scenes. Now, I thought I will move from the theoretical background to an experiential framework and whet your appetite on this topic by using a chocolate cake example, of course. And I've tried three different scenarios: a Britannica Wikipedia search, an internet search, and a conversational AI search, just to show or demonstrate the examples of how these experiences and the information changes. So this is Encyclopedia Britannica. Now, these are digital versions, so I haven't actually physically sourced it. And if I look for chocolate cake, I actually don't see anything. I mean, this is the only example that I see, but it doesn't describe anything further than what it says on this page. And then there is another article on Britannica which is not related to what I really intended to search. So the only one example that was related to cake, but not specific to chocolate cake, was this one, which does not serve for the purpose of what I was looking for. So again, thinking about the experiences versus what we are searching, it may not completely give the answer. Now if I go to Wikipedia, there is a longer page on chocolate cake, and it actually starts describing what a chocolate cake is. Now to be fair, further down, there is a recipe section, which I believe is just one paragraph, so it's not very long. So the point of these two examples is they focus primarily on the declarative type of knowledge. So what is a concept rather than the process behind those concepts. Now if I move on to Google search and I say give me a chocolate cake recipe, what I get back is a series of links and some pictures, images, videos possibly as well. If I do that with DuckDuckGo, just for comparative, I get similar type of results. I do not get anything which is vastly different from each other. The reason for doing this is Google might still present you back the search results based on some other algorithm on top of it. which could be based on historic searches, commercial interest, advertisements, priorities, etc. Whereas DuckDuckGo claims that it is not biased by any of those kind of criteria. So even here, you get the link, but not the information which I was seeking, which is how do I make a chocolate cake? Now if I move on to one of the conversational AI examples, and I give that as a question, how do I make or bake a chocolate cake? I actually get a series of steps of how to do it. If I compare that with another chatbot, so left and right are two different chatbots, I get a similar result, but not essentially the same. And the differences are the measurements to start with. So one of them talks about the weight in grams, the other one in terms of the quantities, tablespoons and cups, etc. So me personally, I'm more on the left-hand side than right-hand side. I always get confused with that. And then I got curious and I was comparing the same chatbot with two different types of questions. Now in the technical word, it is called prompt engineering. That is very specific type of question. So my prompt was, think about yourself as a famous chef or baker, and then give me the chocolate cake recipe. So I'm still looking for the chocolate cake recipe, but now I'm giving additional context, and the result changes. So it changes in the way that the measurements have changed, 25 grams, even though I did not say that I have got additional people. It adds 2 teaspoons of baking powder, which I think is a magic sauce, and then it removes the salt from the other recipe. So it's the same agent giving 2 different responses based on how we are asking the question of the agent. Now, the difference essentially is, just to summarize, we used to have a labyrinth of resources in the traditional libraries, and we used to need a compass, which is the catalog or the index, to go around the library. We don't need that anymore. We get all the information, but the challenges are how do we even know the information we are getting has the veracity and the truthfulness and the factuality around it. So there are some other considerations. In interest of time, I will not go into them in any detail, but I've used a framework of knowledge, so there are some challenges around that, whether it's justified to believe or not, and there are other considerations around privacy, ethics, transparency, and with that, I will close the talk, and thank you again for your time.
Okay. Thanks. Next speaker is Yadidu, who is a lecturer in AI in the Department of Informatics here at King's, and also a Turing Fellow at the Alan Turing Institute. She leads the Cooperative AI Lab. Her research aims to enable machines to exhibit cooperative and responsible behavior in intelligent decision-making tasks. Her work focuses on reinforcement learning, multi-agent cooperation, with a variety of topics that I'll skip. Thank you. Next.
Yes, then you put a link to the slide, but it seems not a.
Oh, I see.
Is this today the slides?
Yeah. So you probably need to just link.
Yes, but it's not. I put it here, but it's not this spec. This downloaded right. Is there an online version?
There's another version of that.
Is there a link that I can access? I think you put that on the.
Because the link that I have is a shared folder on OneDrive, and that was downloaded today, just before the talk.
Okay, so let's. I suggest you move to another slot, right? So yeah. So once we. Yeah, if you can, we'll work out the slides. Yeah, exactly. So if you take a USB stick and you copy the slide on the USB stick and then use USB stick. Okay, so she got the introduction for free. So Yalia, I want to introduce you again, right? All right, so next speaker is Alexandra Jordanowska, who is...
Fine, but before you introduce me, my slides are also missing from this version.
Fantastic, okay, so...
Sorry, these were the,
Yeah,
they're on the
maybe they're
longer
out of order.
version.
Okay, so you didn't even get the introduction, that's good.
I did go back and then.
Fantastic, so we're going... Very nice, so Maximin Lange is next. Do you have the slides?
Yeah.
Fantastic, okay. So I'll do the introduction. Maxim is a PhD student at the Institute of Psychiatry at King's. His main project is building an algorithm that can prescribe jobs to people with mental health disorders.
Thank you.
Very short. Nice.
Yes. I stole my whole topic basically from these guys. Sounds very complicated. It is not. I will explain what they did. They had a really cool algorithm, and they fed 3 million abstracts, just abstracts, not the papers, just abstracts, to this really cool algorithm. I'll tell you about the really cool algorithm and why it's really cool. It can do 3 things. Before I tell you what 3 things those are, more about the algorithm. It's called word to vec. It says, it does what it says on the tin. It converts words to vectors. Because machines, they don't like words, they like numbers. And so they encounter a word, they take it and make it to some numbers. So this, if you see the word, the machine sees the word king, so these are the vectors that the machine likes. Now you can also put them into 2-dimensional space, and what you can see is that related topics are modeled together. Why that matters, we will see in a moment. Again, 3 things. Number 1, they said to the algorithm, again, we can check this out, 3 million abstracts. They didn't tell the algorithm anything. They just put it in. Put in all the abstracts to your algorithm, what do you see? And the algorithm says, if I ask it, where do you see all the periodic system? To the left, you see the algorithm's interpretation. To the right, the actual periodic system. So without any training, it saw the periodic system. Pretty amazing. So that's the first thing I did. Second thing, you can do some magic tricks with it. And this is really cold, hard math. So you take the vector of king, you subtract it by the one of queen, and you go up the distance of the vector of man, and what you get was woman. And now, I don't know what these things mean, right? It's some scientific stuff, but you get the point. There's some, this element is to that element with this, okay? So this cool thing number 2, you could do it. Now the real kicker, number 3, they said, give me words that are close to thermoelectric. Thermoelectric are materials that can take heat to electricity. Again, I don't know the materials there, but that's not the point. The point is, you see, the first 3 are known. The first, actually, 325 are known to be thermoelectric. So they have been mentioned in abstracts together with the word thermoelectric. We know it's thermoelectric. But number 326, we don't know. Why is it in there? It shouldn't be in there because it's not known to be thermoelectric. Same with 345 and somewhere afterwards. And so the top 10 they took it to the lab, tested it, and they all were thermoelectric. How crazy is it? Just from the text. Never has been mentioned together with thermoelectric. So this cool algorithm could do it. I was thinking, can do the same thing with medicine and schizophrenia. And so 3 million abstracts in, basically whole big chunk of PubMed. Number 1, I say like with a periodic system, give me the words, what do you think? 100 random words, we can already see there are some patterns in there. Top cancer and all that, we got disease, we got therapy, okay. Now give me, like with the periodic system, give me disease-specific stuff, especially for psychosis. Okay, cool. Up top, we get common mental health disorders, depression, anxiety. Then we get the psychosis symptoms, the hallucinations, the alogia, all that. Then we got the first generation antipsychotics, we got antidepressants, and second generation antipsychotics. Again, I didn't tell it anything. It got that just from those abstracts. And also, so it could do, number 1, that the other one could do. It could see the things in 2D space. Okay, number 2, that it can do the analogies. So citalopram is an antidepressant. What would be the equivalent for schizophrenia? An antipsychotic, and it could do it. Amazing. And now, for the big thing, can it also see new, never mentioned antipsychotics maybe? So I say, give me things not thermoelectric, but for mine, of course, I want to have something antipsychotic. So I put in imidacloprid is an antipsychotic. What do we get? First 5, other known antipsychotic, one antidepressant, very much expected. And then, again, a whole lot of stuff that also makes sense. What are they doing there? They've never been mentioned with any antipsychotic together in the Puppet abstracts. So I'm thinking maybe those are new antipsychotics. Now, if I did that and if I wrote the paper, put it to a journal, the journal editor would say, okay, it's cool, but validation. I won't just start a new trial just because Max says so. But just sum it up. So it could do all three things that the other one could do, just based off of the Puppet abstracts. And for validation, there's this really cool, again, lots of really cool things here, data set for electronic health records. So all the identifieds from Boston. And I'm going in there and looking if I have 10 new antipsychotics, and I say, in this big data set, are there some that took this, and how were their psychotic outcomes? And we will see. So stay tuned. Thank you.
Great. So I think we're working out on the slides now, right? Yeah. So there is an online version. So the cloud is better than the. Yeah. So we go back to the original. Thank you. Okay, fantastic. So you know everything about Yali,
Okay.
so she can do it.
Okay, great. Sorry, apologize for being delayed about technical issues. Thank you everyone for coming to this event today. So in the next couple of minutes, I think the only message that I would like you to take home is about having an objective view of AI and think about how this would be relevant to your work, to your research, and how this would be relevant and shape the future of AI development. So in terms of the topic that I'm talking about is cooperation in multiple systems. So in terms of the agent, this is a kind of autonomous decision-making systems that would be able to perceive the environment, perceive the task, and take a reflection and do the reflections and take some actions as a response. And especially here, we're interested in the multiple agent system. Where here actually there are multiple agents. So basically thinking about deploying an AI system to the real world. And so this system will not exist in vacuum. So there might be other AI systems existing in the same environment, and they need to interact with each other. Like for example, you get a system for autonomous driving, and when you deploy, so basically they are like autonomous driving cars from other companies, and or even from same company but different cars. And so basically this kind of AI agents need to share the same environment. They need to interact, and basically under this kind of context, so these AI agents may have the same objectives or may have different objectives. So in terms of same objectives, it's like, for example, like traffic signal systems. You want to coordinate a few deep traffic signal systems in the city to reduce congestion, or maybe they have different objectives like driving cars. They wanted to carry out like for example, go from home to some target location, target places as soon as possible. So these are like basically there's like some general and very often encountered multi-agent systems, and there are also a lot of others like intelligent robots in intelligent manufacturing or the supply chains where you have like multiple agents like in warehouses or the vehicles that are moving the goods from different warehouses, and currently especially there's also a very popular topic which is about the language models, ChatGPT, and here actually it brings one interesting multi-agent system into our vision, which is human AI coordination. So we have the AI agent that is a chatbot, and we are humans, and we interact with this AI with this AI chatbot, and we wanted this. We hope that this AI robot, this AI chatbot, would be able to answer our questions or help us to do some to solve some to help us to give solutions to some of the homeworks, or help us to give some ideas about how to write an essay. So this is like a human AI coordination problem. And so basically under this kind of multi-systems, there are a lot of different things and a lot of different challenges that we could discuss about. So for example, especially, so I just go through a few. So for example, one thing is about the partial observation of the environment or of the other agents. So for example, like thinking about the autonomous driving cars. So if you autonomous driving cars. So actually for each agent, they are only able to perceive the environment or perceive the situation in a small neighborhood using their like vision-based cameras or using their like sensors, like radar sensors. And this partial observability would cause some instability for the training, for the learning of the AI agents. And another relevant thing is about the coordination with novel partners. So novel partners will be like, for example, you have some AI, some autonomous driving systems, some autonomous driving cars that you have never encountered before. So you were like, for these AI agents, usually they were trained in some laboratory environments, and you expose this agent to different, for example, different drivers' driving strategies and driving styles, but there are always something new that you have never seen, or there might be some human drivers that you have never seen, and then how could you coordinate with this kind of human drivers to avoid collisions? So for example, you might need to do some reasoning about the types of the other driver, whether they are a polite driver, they would always like to give priority to others, or whether they are aggressive drivers that they always want to take priority of the road, always. And another thing that I want to mention, the relevant here is in terms of multi-agent systems. One thing is whether these agents are sharing the same objective or different. So if they share the same objective, like share the same kind of utility system, like the game of soccer, all the players are coordinating to collaborate, and this will be kind of a easier task. So basically, things how you could distribute the rewards among the agents, among these players. And another scenario is the mixed motive case. So these AI players are having their own private selfish rewards, like private selfish rewards, and in this case, this would actually cause lots of societal challenges of for example, social dilemmas. So if these players are being too selfish, that autonomous driving, they don't want to follow the traffic rules, and they always want to be aggressive in taking out the road, and this will cause congestions. So this will be the challenges coming from this area. And the last critical thing that I want to mention is about some of research from our group that highlights some specific research questions and challenges here. So basically, in terms of the multi-agent collaboration, and on the one hand, so in the standard paradigm, we're interested in given this is a given task or a given task, and these are multiple agents. Like this can be this can be traffic lights or autonomous driving, and they interact with other agents in this new environment. And another paradigm on the right-hand side that is currently important is interacting with humans, like human AI coordination for using the chatbot, or you wanted to align these AI players with humans' values in terms of the humans' values of what are ethical behaviors or what are safe behaviors, and so basically these are just some demos that some demos about how this AI system can be used to solve different tasks. Like this one is about video games, and this is also another type of video games, like the Overcooked is a game from Switch. So basically, we could train some AI agent that could be your partners when you play this two-player game. You don't have friends at hand, and the robot control tasks or the traffic signal or the traffic lights control tasks for some real-world city networks. So here is just an overview of some relevant questions or relevant research problems here, and I think this is generally the thing that I want to talk about today, and I hope that this would give you a generic view of this of AI systems, and how this would be relevant to many of the works that you're working on. And yes, that's all. Thanks.
That's great. There are seats here. Okay, so the next speaker is Alex, who's a senior lecturer at the School of Law here at King's College. She has research expertise in financial crime and corporate crime, the regulation of financial technologies, and the governance of financial markets. The floor is yours.
Thank you everyone for coming today, and thank you also for the Institute for putting together such an interesting and very interdisciplinary event. My talk today will be on some negative consequences of the use of generative AI, in particular with a focus on how generative AI may contribute to the creation of a new AI swindler or AI-equipped swindler. I will be focusing my talk specifically on a subset of financial crime, subset of fraud, which is authorized push payment fraud. I will highlight the links between APP fraud and generative AI, and finally talk to you about some potential solutions of what we could do about it. In general, authorized push payment fraud relies on the use of social engineering scripts that provide realistic-looking scenarios to manipulate or induce the victim to voluntarily transfer funds to the fraudster. So this is at the essence of APP fraud. It very much relies on the willingness of the victim that needs to be manipulated into moving the funds. I've highlighted here, so all these are sort of experts of the types of scripts that have been used in authorized push payment fraud. There are different typologies that are a subset of APP fraud. In particular, what you might find familiar is an impersonation of government officials. So you get a call from the HMRC or from your bank asking you to do something. That is an authorized push payment fraud script. And also impersonation by family friends. So this text here was sent by my 4-year-old daughter at the time asking me for money. It represents a significantly harmful criminal behavior. You can see the cost that APP fraud causes. This is a very fresh report published today by UK Finance in terms of the losses. It also tops all types of frauds currently in the UK, and fraud tops all types of criminal activities in the UK. So it's significantly damaging. What is then the role or the links between generative AI and authorized push payment fraud? My argument is that it can help the crime commission process, and that it can do this with regard to two different components, two different respects. In particular, it can help with optimizing the crime commission process. Generative AI has that capability in general. It has been found to optimize workflow processes in financial institutions or in financial markets, and it can equally help make the commissioning of crime, the perpetration of crime, to be easier, in a way in which it can contribute to creating very skilled, very realistic-looking scripts by very non-skilled criminals. So in general, it can help criminal offenders who don't have any particular educational qualifications, or even if you like criminal career qualifications, or knowledge of different types of business activities, to devise scripts that could be realistic-looking, knowledgeable, as we have seen, and with lots of information, and then also has the advantages of using multiple media to achieve that. And of course, there is easy access. The second component is the fact that generative AI can contribute towards increasing the trust by the victim in the scripting process. This can be done by the fact, again, because the scripts can be made to be more believable. Then second, research has also found that humans are unable to distinguish AI-generated images from, deepfakes from real live humans, and that's a very recent research in psychology. And also, generative AI has the capability of inserting an AI-generated, paradoxically human element into the script, such as, for example, using deepfake technologies to recreate a human person that is familiar to the victim, that so far has been impossible for criminals to do, or impracticable to do. So again, according to the rational choice theory, a prominent theory of criminology, this again makes the efforts and the cost behind the crime commission process to be much lower than the gain and possibility of detection. So again, the crime commission process is much more attractive. To give you some examples of, again, ways in which generative AI has been used, and also connecting to typologies of APP fraud, one way to manipulate media could be through voice spoofing. And this is the process through which a short excerpt of a real person's voice, and McAfee research has suggested that only 3 seconds of voice recording is sufficient to essentially generate a manipulated script or a manipulated conversation. We can see these types of topologies, in particular serial impersonation fraud, have been reported even as early as 2019, before the advent of generative AI. So this again just contributes to the process. A CEO impersonation fraud is an APP fraud in which a company official, usually the chief financial officer, will receive a phone call or an email by the CEO asking them to transfer money to a new bank account of the company because it's needed for business purposes. And that is an ongoing and very significant APP fraud typology. Second, of course, LLM models, large language models, can be used to generate very realistic looking text, emails, and conversations. This is an excerpt from, this image here was part of an attempted romance scam fraud. You can see here the criminals were very sloppy. They weren't very good because they actually left a prompt there at the top. You can see that they asked the LLM module to produce the script. But the romance scam is the second highest damaging type of APP fraud. It essentially relies on fraudsters deceiving the victim into an assumed, a fake romantic relationship, and then convincing them either to transfer their savings or to invest in fake investment scams, notably crypto scams. And this is actually an excerpt from that type of APP fraud. Something that has been really picked up in the news in the last couple of days, you might have read about this case. It was reported back in February 2024, but now the name of the company has been revealed and again renewed attention to this issue. AI can also be used to generate images and videos, of course, including with deepfake technology. And in this particular example, deepfake technology was used to create a fake videos and fake voices to recreate a whole conference call in which everyone was every person at that call, and that included the CEO and other senior company officials, were faked or fake images, except for the victim. And the victim was, again, the chief financial officer. The CEO in that invented conference call asked the chief financial officer to transfer £25 million to 15 different bank accounts, and this is again now intraceable. And of course, the victim believed that the call was real. So you can see all the mechanics that can go behind that. The company that's revealed to be the victim is a very blue-chip technical engineering company, high-profile one, so just to sort of indicate the sophistication behind the scripts and also the sophistication behind the victims. Yeah, so this is not something that just targets really vulnerable individuals. Finally, as victims become more aware that the sort of run-of-the-mill social engineering scripts, such as you get a call from your bank or you get a call from HMRC, there is a need to make the scenography much more complex. And this is where AI, generative AI, can also help with creating fake websites that can have information on fake persons, with realistic-looking information on the business enterprises, and again, to essentially make the scripting process much more complex for the victim to challenge. And then you can see here how cheap it is, in fact, to establish a scam business website. Okay, so now I think the final points of my talk are, what could we do about it? And I just wanted to summarize a couple of points of intervention where maybe we could challenge the use of generative AI for authorized push payment fraud. One approach could be to regulate the technology. But this is not where current regulatory frameworks are moving towards, and it has never been the goal of regulators across the world to sort of approach a curbing effect with regards to the technology itself. It is not also as much a legal question, it is a coding question, and there aren't any attempts to essentially curb the development of generative AI or its learning potential in any particular direction. The second ways in which we are not regulating technology is the fact that a lot of new technologies are available for open use as open software. And this has in fact led to the commodification of large language models. So we now don't have just legitimate LLMs such as ChatGPT, Bard, and so on, but we also have their criminal siblings, WormGPT, and even a younger one, FloatGPT, which have in fact been developed by criminals or criminal groups, and in fact advertise subscription-based services for providing criminal content. So this is a CEO impersonation fraud email here that has been scripted by FloatGPT very easily without any particular obstacles, and then there aren't any SSH checks here to the development of this. And then the question is, what do we do with these providers and with the use of this technology? We could then regulate the creators and owners of them. And this is where regulation has been moving to. There are now, under in the EU in particular, obligations upon, I'm finishing.
Yeah, sure.
There are particular obligations on the owners and creators of large language models, such as OpenAI and Microsoft and so on, to put in place checks to curb harmful content. These checks can be circumvented, research has found that, but also, for example, they are required now to put watermarks on any AI-generated images. Again, doesn't help us with the problem of the darknet advertised large language models. And in fact, FloatGPT is very freely hosted on FlowGPT, which is a type of an app for GPT software. And the final, sorry, this is really not my final points. We could then instead target our initiatives towards empowering the victims. And this is where most of the effort or focus of law enforcement and financial institutions has been channeled into. I think this is a good way, it's a good method, but it's not an answer to all of the potential victimization. So for example, raising consumer awareness has probably helped dip the number of impersonation frauds, such as to a bank official calling you, but it hasn't really helped curbing romance scam numbers. So there will still be part of the population that will be vulnerable to these types of activities. And finally, we can think about enlisting third parties for policing. This is also something that is currently being done with regarding to APP fraud in general, since 76% of APP fraud is generated from online sources. So we can try to task those sources, such as online platforms, but also phone providers, telecommunications, and social media companies, to put in place situational crime prevention checks and disruptions in flagging content that is harmful. We already see that when you get a text showing that it's spam. Now it's also maybe highlighted that it's AI generated. My final suggestion would be, what if we took a radical approach and instead challenge the socioeconomic situations in society that bring towards fraud and potentially, the attitudes regarding perpetrating fraud, but something to think about. Thank you very much.
Okay, so I'll just.
Right.
Any slides here? Yeah, please. Can you go? Okay, so next speaker is Nika Manic, who is a final year PhD candidate in politics at Queen Mary, University of London. Their doctoral research titled Programmable Infrastructures and State Deformation is a historically informed analysis of the British digital state transformation. At King's College London, they work as graduate teaching fellow in the civic and political right. And I think you don't have slides, right? You're gonna. Great.
Hello, my name is Nika, and here at King's, I'm a graduate teaching fellow in civil and political rights, which means that I lead seminars on civil and political rights. And I'm finishing my PhD in political theory at Queen Mary, University of London. And because I get quite nervous when I speak, and because the slides usually don't help me, I'm going to read it out. I can also repeat the title of my PhD. Currently it's titled Programmable Infrastructures and State Deformation. So I'm speaking about the ways in which information technology underpins the creation as well as the transformation of the state. My focus is the UK, which used to belong to an empire. So, let's see if we, okay. Years ago, I heard that the numbers tattooed on the bodies of people detained by the Nazi regime in the Second World War were a product of the categorizing tools by IBM subsidiary Dehomac. I could not forget, and I wanted to understand better how and why it is possible that IBM's complicity is still such an under-researched aspect of the production of structural violence. IBM Watson, a product that IBM introduced in 2010, is named after Thomas Watson, the person who received an Eagle of Honor from Adolf Hitler for his contribution to the cause. My PhD studies a combination of years of research trying to understand how algorithms or recipes, such as Hitler's final solution, rely on computational systems that not solely underpin but also amplify structural violence. In my PhD project, I tried to understand what I dub the soft war through software. The war of my interest is the war on the poor, the war on the disabled, and others reliant on the British state for their survival. Since 2010, the year in which austerity restarted, a technological solution called universal credit created indebtedness as the baseline of deservingness of workfare benefits. Artificial intelligence, on the other hand, became the arbiter of suspicion of benefit fraud. Fraud detection continues to be one of the most important uses of artificial intelligence in the public sector, as we also saw elsewhere. When AI is used for benefit fraud detection, it is not there only to save money. It is there to displace attention from the violence inherent to systems of normalized systemic fraud, such as tax evasion, one of the reasons there isn't enough money for benefits. Tax evasion is often done by the same tech companies that produce the computational systems investigating the fraudulent behavior of people who are trying to survive years of austerity measures. The ones considered risky are the people gaming the political system whose algorithm is austerity. In the beginning of 2023, research by Lighthouse Reports revealed the internal functioning of a benefit fraud risk assessment model used in Rotterdam in the Netherlands. The city of Rotterdam used a supervised machine learning model called gradient boosting machine to learn which variables are predictive of increased fraud risk. The model the investigators analyzed had been processing 315 categories of input data, which the authority gathered from surveying the interactions of the welfare recipient with the authority. The version of the model that researchers were granted access to assigned the highest risk to the following combination of traits. A woman with children, in a relationship for 2 years and having financial difficulties for 500 days. They also learned, and I quote, that mothers with financial difficulties are almost 3 times more likely to be flagged than the lowest risk archetype. Surprise, surprise, men with the opposite characteristics. Surprise, surprise wasn't in the quote. We see that AI helps us see what social researchers, in particular in the tradition of black feminism and abolitionism, has been pointing to for quite a while. And without the need for costly computational systems, the patterns of intersectional equality, AI helps us see as well. But what the AI is predominantly used to is the reproduction of status quo. Katie Richardson once said that AI is like pyramids, symbols of power built on the backs of the oppressed. Palestine is the test bed for training AI products produced by the Israeli tech industry. The Democratic Republic of Congo provides cobalt, the natural resource needed for our devices. The responsible AI community rarely addresses these important questions of responsibility related to the extraction of natural resources to the smallest elements of these supply chains, as well as the communities that bear the brunt of extraction and violence. Responsible, or we could also say reformist AI, does not tackle the source of the issue. For instance, machine learning is simultaneously used for resolving climate change and contributing to it. In 2019, research by Emma Strobel and others showed that training one particular large language model had a carbon footprint as big as 125 return flights from New York to Beijing. I have recently seen a source that said that words will not make a revolution. And I'm not a revolutionary, I'm an abolitionist. And I believe that words do matter. Legal and software code could both be considered revolutionary, and both legal and software code create structural violence. Is conceptual clarity regarding the technical infrastructures, whether we're talking about an algorithm, or we're talking about machine learning or artificial intelligence, whether this is a business term and so on, I wonder whether these technicalities may be less important when we focus on computational infrastructure's role in furthering structural violence. Is being specific about the technical details important if the violent logic behind the systems remains the same? The underlying logics seem to be the same, if not importantly similar, from IBM's punch cards in the Holocaust and the use of lavender AI by the Israeli government right now. Right now, months after the 7th of October and 75 years after the Nakba, students who are in academia for more than just knowledge are setting up encampments They camp for something bigger than them, something more important than intelligence, let alone artificial. They are a sign that we will win. Once solidarity will prevail, once austerity will be a historical policy, and once artificial intelligence will be used to free Palestine, not kill Palestinians, I might reconsider my research and activist focus. I might again, as I did it already, as a recipient of Google Digital News Initiative grant for using AI in political journalism, I might again spend my days focusing on AI for good. But until somebody convinces me that AI for good isn't a decoy, I will continuously emphasize something else, that AI is a political technology of structural violence, one of the many that we should not never forget. Thank you.
Okay, the last talk before we open the Q&As by Ilya Protopapa, who is an assistant professor of marketing education at the business school here at King's. Areas of interest include diversity and inclusion and Gen AI applications in higher education and consumer behavior. Recent work was published as book chapters in both areas.
Thank you. So thank you all for being here today. As very well introduced, my name is Ilya. I'm a lecturer in marketing and also an English education partner. So today we'll be representing the business school and I will be discussing about the project we did and I led on to collect data from our students using AI to address issues of diversity and inclusion within our business school. I'm not alone in this initiative. We had a team, we collaborated with a business partner, Anthony, who at that time was a senior consultant at Deloitte, and we also collaborated with students. We have Kunal here, who has graduated from the business school, and also the KBS 20 team, which is a group of students who assist in research projects. This project was supported by the Race, Equity and Inclusive Education Fund from the King's College London, and in a nutshell, it is a collection of data using AI technology to address issues of inequalities within our business school. And the very first thing I would like to discuss with you is the need for data. So while I will be introducing you to that, I want to start by explaining why do we initiate all that AI project. We wanted to improve student experience, but also to uncover how our students truly feel about issues of diversity and inclusion within our business school and drive actions for our EDI agenda. So what is the need? So far, and people who work in education, we know that we do obtain data relevant to what we call attainment gaps. That means perspective on how students perform, but also how they perceive our institution. However, you must know so far that we do report, government asks us to report data, but these are purely for domiciled students. So that means that even though we do have some quantitative data, they are particularly focused on students coming from the UK. And a few years back, we did launch a Students' Pulse survey to measure and capture perspectives on EDI. But again, that's quantitative data, and that means that we do miss on important qualitative information that will help us to uncover how our students really feel, inner motivations, feelings and experiences with regards to diversity and inclusion. There was an attempt that was led by our inclusive education student partners in 2021, where they facilitated students' focus groups. However, if we look at the literature, there is a concept of social embeddedness that suggests that when peers are interviewing other peers, most likely the participants won't disclose the whole true self. So again, we felt that we really miss on information, and that is happening because they want to be acceptable by the peer group, right? So the solution to that was to facilitate an AI discussion with the use of a platform called Rimesh. And this is why we partner with a business partner who introduced us to this technology. Rimesh is a very popular a platform that is used in the industry primarily, And this is the very first project that they've done globally in higher education institution. Why AI? A couple of things outlined here. First, because it does remove authority bias from members of staff asking students about their experiences, but also address issues of peer pressure and social embeddedness by simply asking participants to join using anonymity without disclosure their identity. It does use journaling approach. That means that that's not an oral conversation, that is a written chat conversation that happens in an online space. And based on literature, that journaling approach really helps our students to uncover their feelings and share even deeper insights about their experience and how they feel. And lastly, that did allow us to reach a wide sample for qualitative investigation. Currently, we reach over 120 students, and it does respect students' privacy. That means that they can join without disclosing their identity. Now, I'm not going to show you the whole video, but just very few seconds from what Dreamers is. As said before, this is the very first project they've done with higher education institution. It's very popular in the US and UK, US-based company working globally, and it does work primarily with employees. So we did a consultation with them and we turned the overall features to match our students' needs. So every time you hear employees, simply assume students.
Connect with an audience at scale using AI to analyze and organize employees' responses in real time.
I will not go through the whole video because of the time limitations, but if you wish to explore, here is the link. It's pretty short to note down. And the main impact we wish to make here is to address issues causing our attainment gap, simply because the data we share with the government are for domicile students, so we really want to expand on international students as well. So those who may not be familiar with attainment gap, simply put, is when students from underrepresented groups are not performing as well as to students from well-represented groups within our higher education institution. Now, as said before, we were not alone. I was the academic lead on that, but we did collaborate with industry. And this is an AI investigation, so we have been particularly concerned with ethical considerations, and this is why we did work with Anthony, as I mentioned before. We're all familiar with Gen AI technologies, however, probably we haven't discussed about that yet, AI for collection of data. So Remus at the moment is one of the leading companies who do that, and that's not, of course, risk-free. There is a very big discussion about how do we collect data using AI. So this is just an example of what Google faced a couple of years ago that has been accused of using homeless people to test their AI technology using AI. So we have been very particular with ensuring quality and also ethical approach on what we do. So Anthony from the industry brought Margaret Mitchell's framework that discusses how ethical AI can be, and basically she has illustrated all the steps towards using AI for generating information, starting from the data we collect, how the model is being trained, the outputs that we generate, and how we act upon these results. The headline of this slide is that every time we discuss about AI, and again, I'm not from computing or AI, I'm from marketing background and EDI, we do discuss about black box methodology. So when we discuss about collecting data using AI, we should be in the position to explain to the participants how their data are being processed or evaluated, and be able to answer any questions they have. So the consultant we had in the team really dropped on this framework and created this sequence of questions for us that we have been asked to report while we go through this process. It's basically whether we need the data, how to ensure that the soundness of the data, whether we made any assumptions, and whether again we were in the position to use the data. The risk element there was quite high, because if within this process any student would report any issue, or even an insult within this AI facilitated discussion, we had to stop, and that was very strict from a quality assurance perspective. So I think I discussed about black methodology, so I think it's important to tell you how does this work. Remus does work as an open-ended discussion, so it's an open-ended journaling approach, and it does ask participants to act upon three elements. First is to answer to the question. Second is to agree or disagree with a given response, and then they exposed the particular participant to different answers from other participants, and they asked to rate their preferred answer. This is how RIMAS creates what we call utility score. Utility score is their own metric for creating preferences, so being able to be in the position to tell which of these topics that they have discussed are preferred. Very important to mention, this is where the natural language processing is coming in. The model is being trained to ignore any increased frequency of words such as this, what, if, they. So, simply put, in our qualitative data analysis, we wouldn't have any theme with meaningless words such as if and they. So, the model has been trained to identify the key themes of the words that would be of a meaningful contribution, if that makes sense. So, again, how does this work? So, this is a short video of what our students has experienced. That's not real, by the way. This is from our pilot study. We would never expose the overall conversation there. So this is one of practice from one of our students. So first they're being asked a question, then they have the time they need to answer to this question, and then they are given other participants' answers and they ask them to agree or disagree. Then they move to the next question, and at some point, we'll see later on in this video, they're asked to indicate which response do you prefer. So getting back to my previous slide, this is how they create the utility scores, so preference towards the answers. Just to make this more clear to you, what does a participant see and do? After responding to the question, they're being asked to agree or disagree with a particular response. This is how they create utility scores, and this is part of outputs that we get. So a couple of responses and the percentage of other participants who agree or disagree with the question. And at that point, it's important to mention there are follow-up questions. So if someone would like to express and share their opinions about whether they agree or disagree with a particular answer that was given, they have a chance to do this within the discussion. And here is the other option I mentioned there. So which response do you prefer? So this is what the participants see and do. This is how utility scores are being formed, and these are some other outputs we have from RIMAS here. So a couple of highlights, number of participants, and a couple of key themes with how many times a particular term came up. Now, I would like to get back to ethics because that was very important in our investigation there. This is our model, and this is a couple of things that we highlighted through this process. It was very important for us, and again, I'm representing the business school, so we don't have AI or computing background to be trained upon the model. So we've been through an extensive training from the company to understand how the technology works in case any of our students gets back to us with any questions. The second consideration there was to ensure that we are diverse in the way we ask questions and we collaborate with students, and at the end that we do address social issues. And this is very important to mention. This is how we collaborate with our students. So our student collaboration was part of ensuring high quality and ethical approach towards collecting data. We did raise some of the questions for our qualitative groups, along with our students and the team of consultants I mentioned before. There was a proper promotion of the project represented by Kunal, our postgraduate student who has graduated this November from King's, who would describe the project, how does the algorithm works and how the data are being used to students to recruit them. And finally, we did analyze the results as a team between consultants, academics and students. So that was a collaborative effort to make sense of the data that we have collected. Few things to mention there. Large proportion of our feedback was positive, but reflecting on some of our EDI efforts, but we did aim to address issues of social challenges we face. So I thought of highlighting 3 key points that we came across that we've never had through any other investigation we had previously at King's. The first one is that students expressed their interest to discuss more about EDI. Second, many of our students suggest that it's not about the diversity inclusion in a general way, or necessarily the racial part, but also financial status, and also the loneliness that some students suggest that contradicts how we do advertise our programs there. Now, I've taken this study to a couple of conferences already, gathering feedback. It might be, especially the second point, an issue in Russell Group universities, but this is still under investigation there. But the other 2 points is certainly something we've seen in other institutions across the UK and some in the US. Just to summarize everything, we did do our final assessment on whether we have been ethical. We can't really claim that we've been 100% inclusive there because there was limitation on knowledge with regards to internet access and the technology to support the facilitated groups, which we didn't have any feedback that some of our students couldn't manage to do that, but we have to acknowledge this as a limitation. With regards to students' tallness, we plan to renew our data after 2 years to make them more recent, because we do acknowledge some of these reactions might be outcomes from pandemic, and we didn't have any assumptions or anything unexpected during this process. And my final slide is, after this investigation, we did follow up with a couple of interviews with the participants. So I thought of highlighting that because I personally started with being very reluctant using AI to address such a sensitive issue of inequality. And then at the end, through the interviews we had, there are some key things that they mentioned. They felt no fear of judgment because it was anonymous. They get to hear about how other students feel. They felt that there's a safe space to share, and that it's good that they heard so many perspectives. So just by that, I believe it was an initiative that offered to some of our students a safe space to share, and we do take their feedback very seriously. So this is what we do now, embed this feedback to our EDI plan. Thank you for your attention and for being here today.
Right, so you've been patiently listening. Now it's your turn to ask questions to our speakers.
Yeah, my question's primarily to Alexandra. We, like you, I know a number of, have been contacted by a number of Nigerian princes who seem to be in financial straits. I'm just wondering whether AI is, most of your examples were high-value frauds, and I'm wondering whether we're going to see this moving to very low-value frauds personalised by AI, and sort of hundreds of thousands of the same ones working rather than a few big ones working.
Thank you for that question. I think the potential usabilities across volumes of amount that can be defrauded. For example, romance scam commonly involves smaller amounts of money. So the CEO impersonation fraud, that could be in the vicinity of millions, of course, and it is commonly. But romance scam, other types of small types of impersonation scams. Another example I didn't mention, invoice scams, where you might be charged 1,000 or 2,000 pounds for a job that you didn't ask for, or it wasn't carried out for you. I think the application is across different types of typologies and across any amount of money. What I think that then the advantage of generative AI is that, again, makes that crime commissioning with little payback, let's say 1,000, 2,000 pounds, to be then multiplied across numerous victims and a greater potential reach that could then compensate for being disrupted in a large multi-million fraud scenario.
Yeah, I'm wondering whether we're going to see a drop to sort of £5 or £10 type frauds. Because I mean, if I get an invoice for £1,000, I check it.
Yes.
If I get an invoice for £15, I might just pay it.
Yes. I think you're
AI
right.
seems to facilitate that much more.
Yes, I think you're right. Yes, and those will be the types of amounts that then victims are likely to not report, because they would either maybe not realize they have been defrauded, or they will be embarrassed to report that type of fraud. And still, I think it was on one of my slides, only 13% of all fraud is being reported by victims. And again, that's probably where thousands of pounds are being involved, and not that low level. So I think we're really lacking intelligence of the use cases in that context. I think we can see the potential already, but we need more research in understanding and cataloging how it can be used with different amounts. And you're right to raise that point. Thank you.
So we'll probably go with Max. next.
Thank you. My question's about cooperative AI. I appreciate this science is very much in its infancy, but what kind of collaborative behaviours have you been able to produce between your agents? How far has it got at the moment? What can it do not to do? Thanks.
Yes, so thanks for the question. I think for the multiple agents, so the primary focus of my work is to explore how this agent would collaborate to promote the social welfare. And so for the collaborative behaviors, what we have studied are mainly under two schemes. One scheme is agents are sharing a same objective. Like for example, we have built some system to train the AI players to collaborate to play the video games. Like StarCraft 2 or the cooking games with humans. So like human player and AI player to collaborate for the common objective. And also some games like soccer, so multiple players to collaborate to play for the soccer game. And on the other hand, on the more general mixed motive cases, so this problem is a little bit tricky. So how could we align the incentives of different players? Because different players are having their individual kind of rewarding or utility systems. And so what we have tried in this case is what we have tried in this scenario is whether we are able to align the players' incentive to collaborate by, for example, allowing the players to share some portion of their rewards utilities with other players, and in return they will also receive some gifting from other players, so that they would have the incentive to help other players. Because if other players get higher benefits, and the gifting that they receive from other players would be boosted. So
you see gifting and almost trading-like behaviours. Do you see leadership behaviours coming through, where one agent begins to simply instruct others?
Yeah, I think this is a very interesting question. So I have a big, so far this is something that I think is definitely very relevant. So it's kind of emergence of different roles in the system. So this is something that we're also exploring at the moment. So for example, it's not, for example, in some systems like taxation. So we have taxation. We might have different roles, like the government who is designing the taxation policies, and all the other people in the system who are just working under this taxation policy. So this government would be like an agent that has instructive roles that would be able to kind of designing some protocols that everyone needs to follow. So in that case, this would this is also kind of involve different type of roles in the system, and how could we enable them to interact, to emerge some better protocols for taxation, also some better behaviors that would be induced by this kind of instructions, like the rules. Yeah.
If I can add something, we also see agents colluding. So if you on the pricing algorithms on Amazon, you train them independently, right? But then there's this emergent collusive behavior whereby they converge to a cartel, which is to a cartel. So they don't compete and they raise artificial prices. So all this study about the emergent behavior of multi-agent system is interesting. And as you said, science is in its infancy.
I was fascinated by how much information clearly waits to be discovered in the massive abstracts, your 3 million abstracts. Have you done any analysis to see, is it worth adding in the conclusions or the middles of the actual body of the paper as well, or is all the information actually in the abstracts?
The main limitation is computing power, because you think the abstract is just 300 words, and when you put 3 million in, how long is the paper? 3,000 words. And so all of a sudden, the model training and the hardware equipment need scales up rapidly.
But you could test the idea on a subset and then see whether it's worth putting in a bid for the resources to do the whole thing.
I can tell you already, it is work. It is big time work, because especially in the abstract, most people exaggerate their findings and say, oh, look, we cured cancer, when in reality they cured maybe one type of cancer in this one demographic. And so all this is hidden in full text, but yeah, the computing limitations.
Thank you.
What does EDI stand for?
Oh, that's equality, diversity and inclusion.
Thank you.
Thank you. Two questions, if I may. One is regarding cooperative AI. If you set the rules, is there or were there any tests without setting rules how cooperation, and if cooperation, would occur, or if they just battle themselves to death?
Sorry, I missed the last piece.
You set the framework.
Yes.
You said cooperate within certain
Yes.
frames, like
Yeah.
taxation, like we want you to cooperate. But did you do any tests without that framework? And if so, how did the AI agents behave?
Yes. So I guess currently, because we're looking for the computational approach for promoting the collaborative behaviors. So currently, one thing one metric that's used to instructing this line of research is to designing some kind of pretty explicit objectives. So like numerical values that we could maximize to measure how good or how bad are the collaborative behaviors are, like the team reward or the collective rewards of different players. So we want to accumulate we want to sum up over all the players, like utilities. We hope that this could be understood as some kind of social welfare and maximize that. So I guess currently most of things are discussed under this computational framework, but I think your question related to something that's might be outside this. So in that case maybe more I can think maybe more some kind of societal thinking or thoughts might need to be introduced to, for example, discussing the fairness or the fairness or some the fairness or maybe fairness can be one thing that need to be considered beyond this framework.
Thank you. And the second question is regarding the scamming. Wouldn't or shouldn't be there an incentive for Microsoft to include Copilot with scamming prevention models? Or I think banks have been developing these measures to detect it, and there should be a race to give customers that option, either as just an advantage for a bank to have your account there, or to make money with that, to protect people from that. So there should be a competition. I am personally quite optimistic that the market has something to offer. Am I right or wrong?
Thank you. Do you mean the market for prevention of fraud? That is the optimistic. I can start with that first. I believe that the market has been developing and producing lots of advanced technological surveillance tools. In particular, if you think about facial recognition technologies, transaction monitoring, which also relies on machine learning. So there is a lot of scope. What I'm not entirely convinced of is the potential use of generative AI for that purpose, because I think that probably lacks the level of legal reasoning that is required to sort of detect fraudulent transactions and then learn from that and apply it. So that is my view of the market. I think there's lots of potential, but not as much as the current hype in the industry. Regarding the Microsoft, if you mean that whether there should be obligations on these companies to have checks and preventions, was that the question about the Copilot and the kind of not allowing scamming scripts to be
detecting it and being and running
to develop their own
checks.
detection.
Yes.
Yes, I think that probably is a great idea, and they probably earn a lot of money from developing that design. But I think that the moment is a bit of a cat and mouse game, and I think that at the moment when a prevention, disruptive tools are developed to sort of identify some fake content, then just models become much better at producing better and more realistic content. But I think you're right that probably the original creators of LLM models, for example, like Microsoft and Bard, probably are best positioned to develop prevention tools as they're developing their models simultaneously, not as a hindsight or as an afterthought after the horse is bolted to the stable.
Yeah, if I can add, so OpenAI has been trying to do watermarking for years. It's not an easy task. Technically, that's the problem there. And it's a cat and mouse kind of situation. And also, on your first question, what happens without the framework? This is linked, so there's this game theoretic way of looking at it. So, in game theory, you study the equilibria, which is a different way of saying emergent behavior, what I said before about pricing. So, if you leave them without any framework, they converge to a certain equilibrium, so you'd like to understand what it is. And then you have a mechanism design perspective whereby you come up with the rules, you impose the framework, and you change the behavior from that emergent behavior to what you want. But this is, the tools we have are very much fun. I mean, they don't make this approach as easy. But, things are developing there.
Can I just ask, you focus on tools to control when scams are generated and to detect them when they're used. One thing that the LLMs can't do, but it is possible, is to generate the sheer number, is to recognise the sheer number of these messages being sent out, and that could be done in the likes of Gmail and so on, who have large investments in AI tools that could be brought to bear, and that would be a viable way to stop them and detect them very early and put those in the hands of perhaps law enforcement. Could you comment on that?
Mm-hmm. So do you mean at the time when someone prompts an LLM to create...
when they use it,
yes.
Perpetrated fraud,
yeah.
The value of it, like the low value scams, and with the high value ones as well, is you have to send out a very large number of them in order to catch a fish.
Yeah. Yeah.
And so the point of surveillance should be in the distribution, not just in the generation.
Yes, I agree. I think there is a large responsibility of the intermediaries of the social engineering scripts, so in particular Gmail and other email providers. Also, online platforms that advertise these types of scams, Facebook, for example, and TikTok, and so on. But if you prompt an LLM to create a script, you can then, as you say, use it an indefinite number of times. But if you have a registered account with Gmail from which you send it, that can be the prevention. But that doesn't exist at the moment, unless the email provider can detect that there is a potential virus content in it, like, for example, macro-enabled Word document or some already established practices. But there's nothing preventing you sending 1 million emails from your current Gmail account, for example.
Could I just add a few points? Is that okay?
Yeah.
Sure.
So from conversational AI perspective, completely agree with your question. I was thinking about it solving for it in 3 different parts. One is the conversational AI front. So I'm looking at the message end to end. One is the messenger, one is the medium, one is the recipient. So if I start with the messenger, then conversational AI has already started putting some moderation filters. So they may not have put it for scam, but they have put it for other kind of things, which are antisocial. So that's the first checkpoint in my opinion. So some controls do need to exist at the conversational AI moderation filters, and those filters work 2 ways. So first of all, they stop the questions that should not be asked, but they also stop the responses that should not be given. So it's a 2-way filter. Then comes the medium. Completely agree with your point. In terms of meaning systems, Currently they scan the content, but what if they started scanning the IP addresses, for example, a location of it? And I know with VPN, etc., it could be masked, hidden, etc., but then that could be raising alarm saying that I cannot detect, so hence it's flagged for your further review. So that's the medium in my opinion. And then the recipient, which in this example is the bank. And banks also need to have guardrails. They already have it for traditional frauds and scams. I used to work for a bank for 2 decades, so I know a little bit about this in the financial crime world. So they already have outlier detection mechanisms in place for the traditional methods of frauds and scams. So they just need to heighten those kind of protections and enhance those. In terms of volume versus value, again, completely agree with your question. But in my opinion, it's a trade-off. So cost plus risk against the benefit. So yes, they can send thousands of it for £1, £10, which we can miss. But to your point, the medium, etc., if they are kind of enhanced, then is it cost effective in terms of sending thousands of them and just hitting 0.001%? Maybe it is, but there would be some trade-off in terms of considerations for that. So I hope that kind of makes sense about 3 different types of controls.
So there are limits already in the main email distributors. In particular, no account can send 1 million.
Yeah.
That will trap.
Sorry, I was exaggerating for dramatic purposes, but you can send many. It doesn't have to be million.
There are rate limits. Furthermore, they are already looking for the training data to be able to learn how to spot frauds. So Gmail and Microsoft 365 both have a report this email option, and that is not just spam anymore, it's spam, it's phishing attack, and I think other. But you can expect to see fraud in that list soon. But they're relying on us to generate the training data, and identifying something as fraud is actually hard. I recently, I believe, turned down a legitimate investment opportunity. I'm reaching the age where they want everyone to split their pocket my pension, because it looked too much like something that generative AI might have generated. And the Wix and the Squarespace web page generators that real people use generative AI to create their pictures. So it looks exactly like a generative AI generated fraud website.
Thanks. Any other questions? Okay, doesn't seem to be the case, so this is my time to thank the speakers for their contributions, and yeah, let's. Yeah, this is also an opportunity to thank you for coming, and if you would like to point your phone there, there's a QR code where you can give an evaluation of your time here. There is, as you may know, many more events until Saturday, so if you want to check out the program and stay with us a bit longer, that would be nice. Thanks. The study is done.
Yes, and also,
Yes,